So I'm Randy Boles. I head the global EHS and sustainability teams at Vertex, and Will Tang, who is also on the phone. Will is our strategic partner and is working in the corporate engineering group, and is kind of like our energy management expert and has helped us, kind of implement some of the plans that we've been putting in place. Um, a few, a f- Probably 6 months ago, we were asked to speak at a better city, and I think that kind of germinated this talk. A lot of the slides are the same. We are a biotech company. We focus on rare diseases. We've been very fortunate in having some success with our therapeutics, and that has driven a good amount of growth, both in the size of the number of people and also our needs for more lab space and manufacturing space, etc., which we have been building out in the Boston area, in the Seaport District. There's our contact information. Happy to talk to anybody offline, if anybody thinks that they'd like to see more, understand more of what we're doing. Just to kind of baseline where we are as an organization and what we're targeting. So realistically, we began our sustainability journey in earnest, I think, about 10 to 12 years ago. I kind of think that was like the inflection point from really a startup to becoming a much more sophisticated company. During that time period, we've reduced our emissions over 50%, absolute, even though we've grown our footprint like four times. So we have like four times the amount of real estate square footage, but our emissions have gone down significantly. That has been primarily driven through green building. So we are a research organization first, which means that the amount of emissions from the actual process is small. Like we could double our experiments and our emissions are not going to go up huge. However, when we double our footprint, our emissions do go up, as buildings really are one of the drivers for our greenhouse gas emissions. So we've been very careful in our strategy to make sure that we are adding new assets, real estate assets that have low footprint, and then optimizing and decarbonizing where we can. So our three-prong approach, we have already reduced 51%. We are committed to another 42%. So we're kind of going in line with the science-based targets. So overall, we're going to be well above 70% absolute reduction when we do this. Even though, again, our growth of our company has been, I think, four times already, and we'll probably add another. It'll be like five or six times growth of the actual facility's footprint, and we'll have a 70% absolute reduction. So it's an impressive story. We're very pleased with it, and we've done a lot to get there. Green building, we are moving towards highly electrified buildings. We'll talk a little bit more about the lab building we're currently working on, and it will be 98% electrified. And obviously, then we can offset that with green energy. Optimizing our current assets. So we do have existing buildings. Some of the buildings are 20 plus years old, maybe even more, especially when you're talking around the globe. And improving those buildings is an important aspect for us. And we do run into some challenges. One of the things, it was funny. I was talking at the ABC meeting, and we said, oh, we're really proud because these are like, gold and platinum buildings and things like that. And someone in the audience said, oh, that's should you even advertise that because that's like the standard. And I said, it's really interesting, but we're a global company, and when you start to look at things like we have facilities in Rome and we have facilities in Paris and things like very glamorous places, but guess what? Their buildings are like 400 years old. and you do not get a LEED Platinum building in the middle of Rome without working really hard at renovating and rebuilding and things like that. So it is not a given when you're talking about from a global footprint that you're going to start with green construction. So as we have continued to upgrade our facilities around the world, we take some pride and considerable effort to make those buildings meet the latest and greatest. So those upgrades come and they do help us, and they're definitely a challenge at times. And then finally, decarbonization, obviously, going to electricity where practical. We have been able to procure green gas in the UK. So we have two facilities, a research facility and a international headquarter office there. Probably total of 800 people between those two sites, and they run on gas from a landfill. So we also look for opportunities like that. Um, This kind of is a timeline of some of the major things that we've done. I won't go through everything, but it gives you a little sense. We started probably where most of us were, 10 years ago, looking at things like, relamping, airflow reductions in laboratories, things like that. We would do optimization, and those were great, like that 2016 airflow reduction project. One of the reasons I say that worked perfect was that we reduced our emissions of our labs by 20%, all sorts of data, analyzing, airflows and everything else. And we didn't get a single person complain about either smell or temperature. And so if you're in the business, you know that, people are so finicky about like just even a degree off. So the fact that we were able to ramp down our emission, our HVAC, to a point where we had a 20% greenhouse gas reduction emission and had basically no impact on 1,000 people. It was a great project. We've then started going into like 2018, we switched over to green gas. We did start to get involved in some of the external reporting, CDP, things like that. And then we started building more and more green buildings, both in 2020, 2021, and now we're in process of a new building going up as well. So a number of things. These were all like step changes. I think we had a healthy approach, kind of like every year or two, we were kind of going that one next step. And I think that to me is what like a healthy program was. This wasn't turned on in like one year, but I think over a 10-year period, you can really see like how we got from, a certain number to 51% reduction. And this all here kind of explains that. Um, I'm going to introduce Will now. So, Will is part of our global engineering team. Our global engineering team is, they support a number of things, but new capital is both in building new buildings and renovating is one of their main mandates. Will is also their energy czar, kind of energy engineer of the team. Has been a great partner. We've gotten so much more benefit. Like I'm in the EHS world, working with somebody that is outside of our world, actually in the design meetings has been great and has really allowed us to bake in a lot of good ideas into the new buildings. So we'll talk a little bit about the engineering team, and then we'll go into the current new project.
Randy, thank you for the introduction. So Will Tang from the Vertex corporate engineering team. From the engineering perspective, right, we have to balance the three-legged stool between uh, project cost, operation, whether it's complexity, maintainability, as well as to meet the corporate goal of sustainability. Vertex has been from Vertex perspective that we've been lucky that we are a growing company, and the easiest thing to do from the engineering perspective is to build sustainable building from the ground up because there's just something we bake into the design. Right, if you can go to the next slide. So our latest building is like 300 more than 300,000 square foot research facility down on the East Seaport. It will support our cell and gene therapy research. This new building, it's anticipated to be 95, like Randy said, 95% electrified. Only less than 5% of the year that will rely on fossil fuel due to the climate zone that we're in. That at this point, that going to 100% electrified is just not um, cost effective. So we say 95% is going to be good enough compared to all the other building that's it's 35% more efficient and 60% more efficient in water. So we're not just looking at energy, we're looking at sustainability as a whole from comfort to energy efficient to water efficient. Um, Next slide, please. Back to the three-prong approach that Randy mentioned earlier, right? Yes, new construction right now to us is the easiest to do, but we do have a pretty large portfolio of existing buildings. I would say combined overall, we have more than 4 million square feet of building worldwide. So a, a new 300,000 square foot building is going to be a very small portion of it. So what we're doing is optimize our existing building via modular-based commissioning. We used analytic tools to identify where things can be performed better and strategize capital expenditure as well as operation expenditure to get these existing systems to their optimal point. Um, next next slide, please. So, and then the last prong approach is, which is the harder approach now, is to electrify our existing stock, right? And what we did is that we built this carbon annihilator, we call it carbon annihilator, to help us to identify projects that it's like the cost relative to the greenhouse gas reduction impact. Things that you see in the green are cash positive as well as that they, I would say the dot on the far right upper right corner, that will be a really it's going to be low cost as well as a high impact on the carbon reduction. There are going to be some projects that going to be high cost and low reduction. So not that we're not going to do them. It's more like we're going to delay them and do some of the more uh, high impact projects first. We basically use this tool to help us identify that our global headquarters, which is about it alone is more than 1 million square foot, is that currently it's say it's I think it's 30% electric use, 30% electricity and 70% gas. We can get this existing building that's built in 2014 to 80% electrified and much less gas. So we're decarbonize our existing stock that way as well. So this is the tool that can help us identify what to do first and how we get there.
And to give people a little more flavor on this, so maybe 3 years ago, we were getting to the point we were making the commitment to the 42% reduction, trying to get in line with science-based targets. And we said, okay, how do we get there? We came up with a list of a number of engineering projects. Will and team have vetted those to various levels. Like we've gotten some external quotes and some amount of engineering study to understand the parameters around it. Like what would realistically be a reduction in greenhouse gas from this project? What are some ballpark figures for the cost to actually implement these projects? And so there is a spreadsheet behind this that has all those projects. And then this is a Power BI dashboard in effect. And it can sort and you can choose which projects you do or don't want to do, and that will then let you see both, the profitability, but also where our future emissions can be based on what projects we might want to do. So we found this helpful. This helped both our thinking, and it's a planning tool that is, that we gives us the ability to talk to the organization and basically map out what we want to do going forward.
Um, yeah, this last slide basically show that once we do reduce our fossil fuel consumption on site, we've been increasing our green sorry yeah green electricity procurement since 2018. So that's how we electrify our building and reduce the carbon emission.
And we are getting more sophisticated with buying renewables. We do have one uh, power agreement. Most of our buys are through Green E-Rex. However, as we look towards both compliance with like Berto, for example, and others in trying to have power agreements and power agreements within your grid, etc. That's probably when I showed that timeline of like every couple of years we get a little more, sophisticated in some of the areas. Over the next couple years, we will decide that we will probably be buying some sort of power agreement, and hopefully we can find a project in the New England grid, etc. That's something that, for example, might be something that we undertake. All right. And I don't know. I saw, Will, that you put some of these in the appendix. I still think some of these are good slides that will give a little bit of an understanding of, because I think we have a cross-functional audience here. Um, we this gives a little understanding of what the building is. Some of the things, maybe, Will, you can give us a highlight of some of the technology and how the engineering team thought about it as they were coming up with a design for the building.
Sure. Um, this thing has to go back to I have to say go back to elementary school type of presentation where we have to first reduce and reduce our energy consumption. Uh, when there's a new building, great, we can build a really high efficient envelope. But for existing building, when we cannot change our envelope, what we have to do is put in um, we replace our existing equipment with a more energy efficient equipment. And in this case, the energy recovery, or some people call it heat shifting chiller comes into play. The reason that that is a really high impact and relatively low cost project is that instead compared to say electric boiler will require basically you put 1 kilowatt in and you electricity in, you get 1 kilowatt out. Heat recovery chiller, on the other hand, is you put 1 kilowatt of power in, you get 3 kilowatt of uh, heating or cooling out. The reason is that we are not producing heat with electricity. We're moving heat from one side to the other. So the heat recovery chiller projects are high on our list for either whether it's a brand new building or existing building, and that's one of the one that going to help our existing building that shift from fossil fuel boiler to more electric base heating and cooling. We also look into air source heat pump, right? That instead of burning fossil fuel, we're gonna use air source heat pump. Similar concept, except that this is more on drawing the heat from the air from the ambient instead of moving it from the chill water to the hot water side. Um, and then, once we reduce the electric demand on the building, that's when we can go. Sorry. Well, first of all, we reduce the demand, right? The next one is we cover the heat with heat recovery chiller, and then we electrify by not using less fossil fuel source, and from there, the beginning is yes, we've been shifting a lot of these emission to scope two, by we can further reduce our scope two by procuring clean energy, uh, as Randy was mentioned earlier.
And just to again give you an idea, this is a 7-story lab building, so it'll be pretty much 100% laboratories. And I think the bottom chart, that benchmark, so looking at a number of buildings. So to Will's point, it's basically right at the top of efficiency. And then of that efficiency, then we convert to electricity. So that's why we have the orange bar there instead of some orange and red. So for this, then this really allows us to not grow our emissions while still growing our footprint, and we're going to add 500 new scientists into this building.
Mhm.
And just a good sustainable solution for that growth.
Thank you, Randy. Like you said, right? A lab is a lab. The lab, hospital, these are one of the more energy intensive user when it comes to into building. So we do what we can to reduce our demand first, and then the next thing we can do is reduce our fossil fuel consumption.
Great. I think that's our overview of the project. We'd love to, before we go further, love to understand a little bit about this team, questions you may have. Our goal here from our end is to be good neighbors and to share. So would be interested in hearing from the team. A little bit about what your thoughts are and what you see in your facility's growth. Tori,
Excuse me. Thank you so much for presenting this. And the approach makes a lot of
oh,
sense.
I'm having trouble hearing.
Is that better?
Yes,
Sorry, it was
perfect.
just thank you so much for presenting it. The approach really makes a lot of sense. I'm wondering, you mentioned you've got, a global footprint, and I think 4 million square feet or something, or four,
Yeah.
yeah. Just wondering if any of that is part of campuses, and if you've had any opportunities to look at district approaches, what that's looked like.
Um, Yeah, so this building is going literally right across the street from another building, and it's going to be connected with a sky bridge. And then we have another building which we have a parking garage which isn't ours, and then on the other side we have another building. So definitely you could argue that this is a campus area. Um, I we have not we. Let's see. So, we do participate with the Green Ribbon Commission. I'm not sure if you guys are
Hmm.
familiar with that. Okay.
Hmm.
So Vertex is, a member or participating with that. I know there is an effort which I think sounds really interesting if they can pull it off to create some very large heat pumps using the river and the bay, and using some anchor tenants like some of the universities, potentially the hospitals, potentially, companies like Vertex. Um, I think that those would definitely be something that, we would definitely consider as they come online. We haven't independently done that, and I would say that we're just getting to the point of a campus size. You're absolutely right. There's some thought process that can start to take place. Boston seems to be like originally we just had one building and two buildings. Now we have, now it's becoming a thing. So it's a very good point. Yeah.
Thank you.
Tori, may I
Bill from
ask who you?
oh,
Yeah, go ahead. Sorry.
hi there. This is Bill from Boston University. Thank you for the presentation. I think we're implementing most of the strategies that you have really outlined here. We're actually coincidentally working on a big heat recovery chiller project here. It took a lot of effort to kind of get that funded with a lot of the constraints that we're having with the federal government right now. But I did manage to get that approved, and we're really looking forward to seeing that really come to fruition. And to the other caller that mentioned, we're looking at the clean thermal energy networking kind of options for the institution. We have a lot of property, but we're constrained by being in the city, so we need permission to cross streets and things like that for our non-contiguous properties.
Yeah. Yeah. We did look at, and it didn't ultimately pan out, but we did look at like a solar array on a nearby garage, and it gets into exactly what you're talking about. Like we had to do it before the street was redone because you want to like get before the meter or after meter, and there's all different economics around these different things. So yeah, we are starting to run into those type of challenges too, but we are continuously looking at those things. In San Diego, we did put on a large solar array, for example, and yeah, we're again, it's not exactly apples to apples, but we are trying to do those as well.
Hi, Jacob from Northeastern. Tori is my colleague. Um, I love the presentation where we were thinking about big buildings and how to. I guess a couple questions are on the design of the building. Did you guys consider geo-exchange, geothermal underneath the building? Um, how are you dealing with domestic hot water if it's going to be kind of a lot of just curious about that with electrification. I've always heard that's an issue. I know it's an issue, and I guess, do you have a percentage of how much of the building is running annually on the air source heat pumps? Um, versus, the chillers, heat recovery, things like that. Might be too much detail, but I'm just curious to kind of understand the all the issues you have to weigh to electrify.
Will, you want to
Uh,
jump in there?
I will, but I'll try to remember one question at a time, right? We did
Sorry, there were a lot in there.
with geothermal, right now geothermal is for the amount of energy that a lab building use, it's not quite there yet, right? But however, for say, I'm going to point to BU, they had a new building, I'm not sure what the name of the building is. I call it the Lego building. I'm sorry if I didn't get it right, but that's a geothermal building, right? And
Correct.
there are certain application for geothermal that can supplement the entire building, but for laboratory building, we're not there yet. And especially, we're here in the seaport area. This type of it all comes down to location, with the type of space and the space constraint we have. It does not make sense, right? Um, I think your second
So
question
you,
is,
you, you
go ahead.
did you did actually we're building a new arena, Matthews our turn on Matthews Arena. And we're going to be building, we're going to install our geothermal wells underneath the building. I know it's a new idea, and I was pretty excited that they all kind of came to it. So I guess the question was, was that ever considered putting wells underneath the building? It just wasn't even an option.
Um, I could not answer that for you, right? A lot of these are actually in partnership with our developer,
Gotcha.
and I'm pretty sure the location, it and also the intensity and the cost, right? We have to balance a lot of stuff, and cost is one of those that would say geothermal did not make sense for
Totally
laboratory.
understand. I just was curious if that was ever an
Hmm.
option. Um,
Yeah. And then when it comes to your second question on the domestic water, our domestic water is actually electric resistant, not heat pump.
Gotcha.
comes down to balancing costs and operational costs and as well as the initial capital costs
Yep.
for that. And we make the decision to go with electric resistant. We're not using gas, but we're going with electric resistant instead of heat pump technology. And as for the air source heat pump for the building, that's where the 96% electrified comes in, right? Or 96% is, I want to be careful with that. We anticipate to be more than 95% electrified most of the year. Um, so I just want to be careful with that. What it is that due to our climate zone here in Boston, that it can get really cold, and the technology right now, they say they can go down to negative 4 degrees or whatnot. There's still time that just won't able to supplement the whole building, and that's when the remainder of the 5%, or when there's in case of emergency, we will have to burn natural gas to heat the building.
This may be too technical. I mean, I was trying to get at like because one of the things we were thinking about our buildings is air source heat pumps, a lot of draw. You want it to, you can't just running a big lab building all on air source heat pumps with all the demands could, it's big. So, and obviously with the ex heat recovery and all that stuff, that takes a big portion of that out. But I was just curious if you have a number, like, is it how much is just do you have kind of allocated towards air source heat pumps? Like half of the building's thermal load is covered by, I mean, just I'm just curious because I'm thinking about, our future buildings and the demand that, go all electric will be and trying to find, different ways to
So you're asking the electrical demand that allocated to the air source heat pump. I do not have that on in
No,
front
no,
of
I
me.
was I was more just the overall heating. So like, it's a stack, right? So like 30% is provided by the chiller heat recovery, another 10% is provided by the recovery from the exhaust air, and maybe another 30-40% is provided by, air source heat pumps. I'm just trying to understand, like get that kind of rough stack
Got it.
of like of,
I do not have that number in front of me, but I can certainly
yeah, it's
provide that
pretty
for
it's
you.
pretty it's pretty technical. I was just curious because
Yep.
thank you.
This is where the reverse triangle comes in. We're reducing our low. The very first thing is actually reducing our heat outdoor air heating demand, right? We are
Mhm.
recovering the heat exhausting through the exhaust unit, because laboratory building, we have to run 100% outside air. What we also do is what we're doing is that decoupling our ventilation from our thermal load, right? So we're providing um, ventilation to meet our demand for the air change that's needed for the particular lab, and then we're using fan core or air active chill beam within the space to recirculate the air within that space, that one lab, so there's no cross contamination,
Well,
and provide thermal comfort. So that alone reduce the amount of outside air, right? And then the next reduction on the low is to recover the heat on that outside air, but before they get to before being exhausted out. What's very advanced technology on this particular new building, what we call LC2, is that we are using the freeze thaw technology. We're freezing the exhaust air before it goes out, and you can actually get a lot of heat out of 32 degrees ice.
mhm.
Not necessarily geothermal, but something for other people to consider is to thermal storage, right? If you think about it, we didn't do it here on our building because of the quantity of space needed, but 32 degrees ice is actually a lot warmer than 14 degrees ambient air on a winter day here in
Yeah.
New England. So there's technology out there that it is existing technology that we can incorporate into our building system. And for campus, that might be actually a more very viable solution.
Interesting.
But I can definitely look up on what's the percentage of the heating of the building on the degree day that's coming from the air source heat pump, from heat recovery chiller, from the uh, exhaust source heat recovery. I can follow up with that.
If you don't mind, then no big deal if it's. But thank you.
Great. I don't know if there's any more questions or comments.
Not seen any more hand raises or anything in the chat. So I think that rounds it out. Give people one more second. I want to jump in. But otherwise, yeah,
So I was just going to say this
Right.
building,
Yeah.
so this building is scheduled to come online in Q1 of next year. I'll throw it out there. I think that I'm sure we'll be doing tours. It's going to be a beautiful building. So if next year at some point there is interest by some members to connect and potentially have a view of the building, I'll just put that out there. So
Very exciting. Thank you, Randy. All right. Well, I will end the recording, make sure I send this out, and then Randy and Will's contact information will be in there too. Thank you for offering to answer any questions offline as well for follow-ups. But yeah, I'll send this out. Thank you all for coming.
wonderful.
Thank you, Abby.
Thank you.
Great. Thank you, everybody.
Thank
Nice
you all.
meeting you all.
Yeah.
Bye.
Thank you.